Hey guys, so I actually forgot to record our lecture from this morning, so I thought I would go over the examples again, just in case you guys needed to kind of, look at the lecture and see how we solve these problems. So I'll just go over the two examples that I had talked about in class. So hopefully this will help you, when you're working through your homework or just studying for the test. So this one over here, as you can see, is talking about, in 1948, an organization surveyed 1100 adults and asked them, are you a total abstainer from, or do you on occasion consume alcoholic beverages? So out of those 1100 adults, 407 said they were total abstainers. So this was from 1948. And then in a recent survey, the same question was asked of 1,100 adults and 330 indicated that they were total abstainers. So as you can see, the first question is they're asking us to find sample proportion for each one of these samples, so from 1948 and the recent one. So when we're talking about sample proportion, we are talking about finding just basically what percentage of the people said they were total abstainers compared to, the total number of people that were surveyed. So our X1, N1 value is going to be from the 1948 survey, and X2, N2 is going to be from the recent survey. And then based on that, we will calculate our sample proportion, which will be the P1 hat and the P2 hat. So for our X1, that's going to be the total number of people who said that they abstained from alcoholic beverages. So that's 407. And the total number of people in the survey were 1,100. So that number will go here. For our X2 and 2, that's going to be the recent survey. And in that one, 330 people said they were total abstainers out of the 1,100. So this will be 330 and 1,100. Alrighty, so now to calculate our sample proportion for the first one, I'm just going to use the built-in functions to help me out. So this will be equal to, and we're dividing X1 by N1. So you will see I'm going to click on the box for our X1, divide by the N1. So just using those cells, you can type the numbers in if you want, but I'm just using the cells to calculate this. Same thing we're going to do for our recent survey. So that's X2 divided by N2. So again, I'm going to click on the cell, divide by the N2 cell, and you will see it does the calculation for us. So there is a little bit of difference that we are seeing in those sample proportions, right? For the 1948 survey, the P1 hat, we have 0.37, whereas for the recent survey, the P2 hat is 0.3. So these are the numbers we're going to plug into our first two answer boxes. So 0.37, and we had 0.3 for the second one. So we'll just check those answers. Alrighty. So now you can see we are saying, has the proportion of adults who totally abstain from alcohol changed? And they want us to use the alpha level of significance as 0.10. But before we can get into those calculations, the first thing we have to see is, are we able to do hypotheses testing? So will our requirements be met over here? So, for most of the time, we will talk about our sample size being less than 5% of the population size, because just imagine, even in 1948, the 1,100 people that were being surveyed has to be 5%, less than 5% of the total population. And, obviously today, in today's times, for recent times, a sample size of 1,100, again, is going to be less than 5% of the entire population. So yeah, we can definitely say that our sample size is less than 5% of the population. Now, are our samples independent? Yes, they are, because the people who were surveyed in 1948, they're not going to have an effect on who was surveyed in the recent years. So obviously those two samples are going to be independent of each other, because one sample does not affect how you end up choosing the second sample. So our samples are independent. Now, the third thing we have to check and see is when we multiply our N1 P1 hat and 1 minus P1 hat, is that total or that product going to be greater than or equal to 10? And then same thing we need to do with our second sample. So again, I'll go back to my Google Sheet over here, and you can see I've put these formulas in here for us to, collaborate with. So again, I'm going to use equal to. Now we're supposed to multiply N1. So again, I'm going to click on my N1 cell, multiplication. Then we multiply with P1, and we just calculated P1 over here. So I'm going to click on that cell, multiply again. And then we have to do 1 minus P1. So I'm going to put that in parentheses. So open parentheses, 1 minus. I'm again going to click on my P1 shell, close parentheses. And we have to see if that number is going to be greater than or equal to 10. And you will see it comes out to be 256.41. So yeah, that's a pretty decent size number, right? Repeat the same process here with the second sample. So this is now going to be N2. So I'm going to click on that N2 value, multiply by P2. So that's the 0.3 over here, multiply by that. And then again, in parentheses, I will do 1 minus P2, which is again the 0.3 value. So I'm just going to click on the cell, close parentheses, and that gives us a number of 231. So yeah, you can see when we do those products, both these numbers are going to be greater than 10. So that means our third requirement is also being met. So sample is less than 5% of population. Both samples are independent, and we have our product greater than 10. So we can go ahead, check those answers. So this now gets us into our hypotheses testing. So as you can see, we need to identify our null and alternative hypotheses. Remember, P1 will represent the population proportion for the 1948 adults who abstained from alcohol, and P2 will be, for the recent adults abstaining from alcohol. So in this case, we want to know basically, did our population proportion stay the same from 1948 to recent times? So this would be, is P1 equal to P2 for our null hypotheses? And then for the alternative would be, P1 is not equal to P2. So those would be our null and alternative hypotheses. Again, check your answer. Now they are asking us to calculate the test statistic. So let's come back to our Google Sheet here. So it's this formula over here that is your test statistic. So this is what they're asking us to find. So you will see part of this formula is the P1 minus P2 hat on the top, which are these, proportions we calculated right at the beginning. We have our N1 and N2 values, but we need to actually find what just the P hat value is going to be. And that's where this formula is coming into play. So you can see this is going to be our P hat value. So as you look at the formula, this one here is where you add both the X1 and X2 values on top. I'm going to put that in parentheses. So again, just click on the cell for X1 plus X2, close parentheses. So that's my numerator. And then we divide this by the denominator, which is N1 plus N2. So again, I'm going to put that in parentheses. So N1 plus N2, close our parentheses, hit enter. And you can see that's what our P hat value comes into play. Now you will see it automatically calculated the test statistic here because I have already pre-programmed that formula in the cell already. So you can see I have my two cells for the numerator. So that's the P1 minus P2 over here. So those are these two cells here. Then for the denominator, we have square root of P hat minus, P hat multiplied by 1 minus P hat. So that's this cell over here. So that's part of the denominator. And then I multiply that with the square root of 1 plus N1. So that's my N1 cell over here, plus 1 divided by N2. That's my N2 cell over here. And then, just putting all of that in parentheses. So I've already pre-programmed this formula in here. So, as soon as we got done calculating the other numbers, your test statistics would be calculated. And you can see this number is coming out to be 3.478, and then it keeps going from there. So this is one way you can calculate your test statistics by, basically using this formula. And this is from your textbook that I've copied it over here. Or your other process is to use StatCrunch. And I've actually put the menu options that you need to follow to come up with, where you can do your calculation at. So you first open up your StatCrunch. So let's go back to our problem here, and under question help on the top right hand corner, you will see if you go down the menu options, we have StatCrunch. So click on that, let it open up, do its thing. Once you go there, it's open, you go under stat. So you will see again, I have those instructions here. So from StatCrunch, you go to stat. From stat, we go to proportion stats, then to sample, and then to with summary. So again, StatCrunch is open now. So go under stat, proportion stats. Since we have two samples, right? One from 1948, one from the recent times. So that's two sample. We don't have the raw data. All we have is how many people said they abstain and how many total were surveyed. So that's why we're going under with summary. So over here, let's see, let's go back to our problem. Okay. So in the 1948 survey, 407 people said, that should be a 407 people said they abstained out of 1,100. In the recent times, we had 330 people who said they abstained out of the 1,100 who were surveyed. Now, the other thing is, of course, we are doing the hypotheses tests. Is P1 equal to P2? So if you will look at this equation that they are coming up with, and I'm going to try writing this out, but I'm actually using my finger, so it may look a little, weird. You will see over here in our problem itself, we have P1 equals P2. But, if you try to bring them both on the same side, so let's say we go ahead and subtract both sides by P2. Of course, you will see these guys will cancel out on the right-hand side, and we will end up getting P1 minus P2 equal 0. So that's actually rewriting that null hypothesis from the beginning. Okay, not sure what happened there. So that's going to be, our null hypotheses basically rewritten in this format, and that's what you have over here, P1 minus P2 equals 0. And in that same way for the alternative hypotheses, we end up getting P1 minus P2 is not equal to 0. So that's giving you your second one. So there's the same, relationship. It's just being rewritten in a different format. Alrighty, so I'm going to clear this out. And so just, select your null hypotheses. Just make sure these guys are, 0 and not equal to 0 here. And then all you have to do is click on that compute button at the bottom of that window. And you can see we have our calculations. So these are the two numbers we entered from the 1948 survey, the two numbers from the recent survey. This is showing you the sample difference between the two, proportions. So if you just look at these two numbers, if you took, a difference between them, you subtract these numbers, you are going to end up getting 0.07. That's your standard error. And then this one over here, the Z stat, that's actually your test statistic, this Z sub 0 that we just calculated in our Google Sheet. So you will see this is 3.478. And let me show you our Google Sheet over here. And you will see this number was also 3.478. So exactly the same number. We just did this using the formula. And this one over here is using, StatCrunch. So let's go ahead and plug this number in. I believe they want us to round this to 2 decimal places. Yeah, 2 decimal places. So this will become 3 point. And since you have 478, that 8 makes the 7 go up. So that will be 3.48. So 3.48 is going to be our test statistic. Now to calculate this p-value over here, of course you can use the textbook version, where you use the normal distribution table and use that to help you out, or you have actually already calculated the p-value in the StatCrunch over here, and that's this number right over here at the end. So you will see how this is 0.0005. We have to round this to 3 decimal places. You'll see that right here at the bottom. So 3 decimal places, this guy will become 0.00, and the 5 makes this number go up, so 0.001. So that's what we're going to plug in here, 0.001. Check that guy. Okay, now to interpret that p-value, basically the idea is, if both are sample proportions, or in this case population proportions, would be equal, one would expect that a sample difference proportion would be greater than the absolute value that is being observed from our p-value over here. So you will see how this number is 0.001. If I had to rewrite that, in a fraction, 0.001 will become 1 out of 1,000. They want this, how many out of 100 repetitions, would work on this experiment. So since you're doing 1 out of 100, that's the first 2 decimal places, which is 0 out of 100. So technically, we would have 0 out of 100. So if the population proportions are equal, one would expect our sample difference proportion greater than the absolute value of one observed in 0 out of 100 repetitions of this experiment. Okay, and then for our last part, let's clear this out. For our last part, they want to know, well, then in this case, what happens with our hypotheses test? Do we reject the null hypotheses, or do we accept, do we reject or do we not reject the null hypotheses? So remember, the rule of thumb is your p-value has to be less than alpha if you are going to reject your null hypotheses. So remember, they gave us the alpha value right here when we started part B. They're telling us use 0.10 as your alpha. So that is going to be 0.10. Now let's take a look at what our p-value is. And, of course, you will see our p-value is 0.001. So 0.001 is definitely smaller than 0.10. So, of course, this tells us then that we need to reject our null hypotheses. So since you are rejecting the null hypotheses, you now have to choose, is it going to be between option A or is it going to be between option C? So let's read both of them. It says, reject the null hypotheses. There is sufficient evidence that the alpha 0.10 level of significance to suggest the proportion of adults who totally abstain from alcohol has changed. Or your second option is reject the null hypotheses. There is not sufficient evidence that the alpha equals 0.10 level of significance to suggest the proportion of adults who totally abstain from alcohol has changed. Well, we do have evidence, right? Because we have calculated the p-value, we have our test statistics, and we can see that our p-value is less than our alpha. And so in this case, yes, we do have evidence, and it's going to be the first one, option A. And you can see that just even in the sample proportion over here that, obviously there is a little bit of difference in our proportions over here. By the time we go through these calculations, we can definitely with confidence say even in the population proportion, we have a little bit of difference, and that's just kind of got proved over here. So P1 is not equal to P2. So the two proportions are not equal to one another. So just, to show you how you can use StatCrunch to help you out with some of these calculations. But, obviously, like I said, you can also use Excel or Google Sheets to help you out with those calculations as well. Alrighty, so let's take a look at another example over here. So this one is talking about a survey asked how many tattoos do you currently have on your body? Of the 1,212 males surveyed, 179 said they had at least one tattoo. Out of the 1,006 females surveyed, 147 said they had at least one tattoo. So they want us to construct a 99% confidence interval to talk about, whether the proportion of males have at least one tattoo differs significantly from the proportion of females that have at least one tattoo. So for this one, you can use the formulas that you have in your textbook. So this is on page 474, and you will see these are the two formulas, for your upper bound and lower bound to calculate, those bounds for your interval. Or we can use StatCrunch for it. So, this was from our previous example. Let's close this guy out. There's our problem. So for this one, when you're using StatCrunch, you're actually going to follow the same route that we did in the previous example. So you're going to go under Stat, then we go under Proportion Stats. We have two samples, right? One for male, one for female. And we don't have the raw data, we just have the summary. So you want to click on with summary. So under sample one, we'll put the male information. So that was 179 who said they had at least one tattoo out of the males, and a total of 1,212. For the females, we had 147 females who said they have at least one tattoo, and a total of 1,006 were surveyed. Now you will again see this is a 99% confidence interval that they're asking us to construct. So by default, this is always on hypotheses test, but since we are doing confidence interval, switch that. And again, by default, they have 95% here. You want to change that to 99%, which will be 0.99. And then just click on compute. And you will see we have our lower limit of negative 0.0373. We have to round it to 3 decimal places, as you can see in the instructions here. So this will be negative 0.037. So negative 0.037. And then for our upper bound, we have 0.0404. So this will actually become 0.040. Okay, we can check our answer. Click on continue. And, before we get into that part, just to show you the different information you have available here, of course, this is the data we entered for the males that were surveyed and the females that were surveyed. This is showing you the difference between their two proportions. So if you calculated, the sample proportions for this guy, this would be the difference between them, your standard error, and then of course our lower and upper limit. So, since we're talking about 99% confidence interval, you're choosing between options B or D, because that's where they're talking about that 99% confidence. If you look at options A or C, they're talking about 99% probability. This is not a probability. This is a confidence interval. So the idea is, do you think we have sufficient information, or sorry, if we have insufficient evidence of a significant difference, or we can conclude that there is a significant difference. So looking at the interval, you kind of have to decide, okay, are we looking at yes, we can conclude there is a significant difference, or we have insufficient evidence that there is a difference between the male and female. And I would say there is insufficient difference, because again, look at how small those bounds are, right? So let's check this answer. Well, there we go. And so you have insufficient evidence of a significant difference between the proportions of males and females who have at least one tattoo. So again, this was just to show you, how you can kind of use StatCrunch to help you do these calculations. All right, guys, so this is basically what we had talked about in class today. So I hope this will help you out. All right, take care, everyone.